All right, hey everyone, this is Team VES NLP, and this is our final project video. So to start things off, here's a quick run through of our project. So basically what we've created is a virtual smart home, and the user can interact with the devices in the smart home virtual space with pure spoken utterance. For example, you can open a microwave, close the microwave, and you can do these by simply gazing towards the object. Doesn't have to look exactly at the center, and then give a relatively fuzzy verbal command. So something like open this or open would also work. This is a pipeline design for our project. So starting from the Unity front end, we collect raw data, which includes the user's spoken utterance and spatial information. We send the spatial information, which includes the cosine distance and Euclidean distance, to our preprocessing spatial algorithm, which calculates the cosine distance and Euclidean distance between the user and the objects in the VR space. We process the user's spoken utterance audio using Unity's built-in speech-to-text function, which gives the utterance in plain text. We process the text in an NLP model and get the user's action intent and or target if that is also being mentioned in the utterance, like in the case where user says, open the microwave. The target, intent, and the pre-processed spatial information will then be sent to our multiple machine learning models for prediction. We have 3 machine learning models, namely the multiple linear regression, naive Bayes, and decision tree. The models would also take a predefined list as an input, which is the object availability list, and contains information about which actions are supported by which objects. Finally, we'll ensemble the outputs of our 3 models with a simple voting method. The target that wins the majority vote from the 3 models and the predicted intent action will be sent back to the Unity front end. So here are some preliminary results of our model predictions. Currently, we're training with 27,396 pieces of data, and our MLR model has the best accuracy of 0.9712. Our naive Bayes model's best accuracy is 0.9045, and our decision tree model's best accuracy is 0.9789. So in order to test our overall workflow, we conducted a series of end-to-end evaluations. Since we're using the built-in speech-to-text function in Unity, and our NLP model has been performing relatively well and stable, we decided to focus the evaluation on machine learning models. We performed an open-close actions on 7 targets in the VR space and tried to angle at 5 different directions on the target, the object center, top, bottom, left, and right. So here are the results of our evaluation. As you can see at the very bottom, the MLR has the accuracy of 0.85, and the decision tree and the naive Bayes model correspondingly has 0.94 and 0.97. The voting strategy actually works surprisingly well for our tests. Among the 70 cases that we performed, the accuracy of the final voter prediction is 100%. There are a couple of things that we can extend in the future for our project. First, we want to support for more complicated utterance to interact with the objects. For example, for the 4 stoves, we could allow the user to refer to a specific one of them by saying, turn on the stove at the bottom right, or simply turn on the stove on my left. We also want to support egocentric interaction and carry on devices and objects. An example would be if the user picks up a pair of headphones and say, play music, the music would then come out of their headphones instead of the boombox that is placed in the room. We also want to further improve our accuracy, especially in the corner cases where 2 potential targets are positioned very close to each other and the intent can be acted on both of them. And lastly, we want to collect and use more spatial information such as hand position, eye tracker, etc. That's it. Thank you.